Hi, everyone. Welcome to Unfiltered, a show where we discuss interesting topics with folks at the fringes of cybersecurity. We're happy to have with us today Dr. Prashant Doshi, Professor of Computer Science at the University of Georgia and Director of the Think Lab. He's also a faculty fellow of the Institute for Artificial Intelligence at UGA. He's joined today by two of his proteges, Omid, a final year PhD candidate, and Aditya, a graduate student, both who work on Think Lab projects in AI-based log inference and attacker intent recognition. We're really happy to have you gentlemen on the podcast today. You're our first academicians, and you've been doing some pretty crazy work, and we're hoping that you can kind of take our audience through kind of through the work that you're doing, how you came to these areas of research. And as we go through, please feel free to kind of go into the weeds. We sort of like to get into the technical details a little bit. Before we get rolling, it's always nice to learn a bit more about our guests. So Dr. Doshi is a fitness enthusiast. He's currently prepping for a local triathlon. Omid is a car freak. He likes them in all shapes and sizes, as he has told us. And Aditya is a budding ukulele player. So that gives you a bit more context. So hopefully their professional accomplishments as we'll hear today will be much more interesting than the rest of the stuff that they're doing. But we're going to jump right into it. So maybe Dr. Doshi, I'll start out with you. AI in security, it's all over the place. It's in academia, it's in industry. It's become almost a heavy buzzword when you're on the chief security officer side of the table. Maybe you could talk us through this. This is your area of expertise. Maybe you could talk us through what's real and fake, your view of the state of the art. I think that would be a great starting point for our audience.
Sure. So first of all, thanks, Sahir, for having us on your podcast. We're really excited to be here. And you're absolutely right. AI has become a real buzzword at this point where, everybody wants to be doing AI and everybody wants to be known, doing AI. And much of the AI that's currently happening, it kind of falls within the machine learning side of AI. But as somebody who has been in AI for many years now, I think I've been in AI for almost 2 decades now. There's a lot more to AI than just machine learning. Of course, this is a really happy phase for AI. And I think that because of this attention on AI is seeing a lot of progress, a lot of investments. So I'm really happy for AI. Now, as far as AI's role in cybersecurity is concerned, I think that every company, every academic group wants to be doing some kind of AI, and show how it is useful in cybersecurity. From what we have been seeing in our readings, much of the AI that is being used in cybersecurity is on machine learning, and much of it is still focused on the detection part of machine learning. So, in my lab, we often like to sort of have a layered approach to cybersecurity, where the bottommost layer is about detection. So this can be intrusion detection. Then beyond that, we can go for attribution, where you sort of attribute the type of attack and other facets of the attacker. And then we have the intent recognition, where you try to understand, the intent behind the attack. So what is it that the attacker wanted to do when there was an intrusion in your system? So much of the AI that we are seeing so far, the AI applications, they have all still been at the detection phase, where you use machine learning to understand, how the attack played out, and then you try to use machine learning to predict the next step of the attack. That's where I think much of the work we are seeing, and where some of the really deep learning pipelines have been built. So certainly I think it's a really important thing to do to be able to predict the next step of the attack so that you can stop it or you can preempt it in some way. Um, but in my lab, because we have such a pure AI background, we felt like we could do more than that. So in my lab, we are very focused on the attribution and the intent recognition phases. And we have gone sort of we are not just focused on machine learning, but we are actually focused on other aspects of AI, sort of the more cognitive side of AI, where we focus on using decision-making frameworks. We focus on using, we have used machine learning, but our focus really has been on using decision-making, planning, cognitive frameworks to understand the attributes of the attacker and to understand the intent of the attacker. So we're really trying to go beyond, what's being currently being done in the industry.
I think those are very sort of interesting use cases, and we want to double click on kind of both of those. Um, Before we kind of get there, maybe two questions. One is what sort of led you to these two spaces? They're obviously novel use cases in cyber. I don't think there are many folks who are working on these two problem statements, but they're obviously very important, and they're not. At least I don't know anything on the industry side that is really probably shipping product that even has these types of capabilities. So if you guys can get this developed, it's going to be, it's going to be quite crazy. But what was the sort of the driver? Did you guys sit down with a bunch of use cases and then say, here are some really interesting ones? Or what was the sort of aha moment that these are a couple we could pick?
Yeah, I think that's a really great question. And so, our context is for these investigations into attribution and intent recognition. Our context is cyber deception. So we're really interested in sort of, how can we engage with the attacker to know more about the attacker, so that ultimately we can deceive the attacker.
Mm-hmm.
And that's been the overriding context. And how we got into this is really, not much different from basically the industry. We actually managed to win an army based grant competition. And so we basically won an army grant to investigate AI and cyber deception. And so essentially, it's the funding that led us to this project. And there's a lot of interest now in moving towards cyber deception, among the various funding agencies here in the US. So I think that, the key that what we are trying to do is that we are trying to take a more cognitive, a more sort of an epistemological approach, where we are trying to understand, um, sort of the beliefs of the attacker, the capabilities of the attacker, the intent of the attacker. And we are all when you're trying to do all of this from data, just from the data that you have. So from the log
Yeah.
files that you have, trying to make inferences on the log files, using really sophisticated decision making frameworks that reason about the other agents as well, and trying to use these sort of exploit the capability that these frameworks have, and see how far can they take us in the cyber deception domain. So we are very much grounded in cyber deception, and that's why I think I really like what your company is doing, Sahir, because I think your company is also in cyber deception, and it's sort of rare to find many companies who are focused on cyber deception. So I think your company's work and my lab's work is a really good match.
Yeah, I do agree, Dr. Doshi. And maybe a quick tip to sort of, we get a number of chief security officers out there that kind of are always pummeled by this AI ML messaging. If you were sitting down with them across a dinner table and they said, hey, Dr. Doshi, what's your top tip for weeding out the BS from, from reality? I mean, and that's probably going to set you off on a long conversation. But what's like the biggest, like, this doesn't pass the smell test for you? If you hear about a vendor claim or something, what's the dead giveaway for you that nah, that doesn't add up?
Right. Well, I think AI is really trying to be sold as a commodity. So that's why much of the big tech, the big players and even the smaller players, they really want to use AI as a buzzword. Sell basically, just kind of proclaim that they're using AI in their products. And to me, my threshold is when you try to claim regression as AI.
Mm-hmm.
So if you're just trying to do logistic regression, or if you're just trying to do some kind of simple curve fitting, and then you say that what I'm doing is AI, I think that's where I draw the line. That
Right.
this is not really AI. This is just simple, plain statistics,
Mm-hmm.
and I think there's a lot more to AI. So
Yep.
now I don't consider myself to be a deep sort of a deep learning researcher. We do deep learning, but if all you're really doing is applying a sort of a two-layer convolutional neural net to your data, and then hoping that the predictions come out well, and if they don't, you spend like hours and hours tinkering the architecture. That's more engineering than really doing AI, right? Because you're
Right.
using an existing framework and just tinkering.
Yeah.
So I don't really want to pass judgment on what AI is and AI is not. But I think that there is a separation between just doing plain statistics on your data and then calling it AI. So that's probably where I would draw the line. Now, of course,
And
what we are
hmm.
doing in my lab is just really pure AI. It
And
actually
how
gets
hard, how sort of, sorry to jump in, but I know earlier it was hard to get sort of training data sets which were, realistic, real world. How much has that problem statement evolved? Is it still a challenge, or is it opening up? Are there some initiatives that are kind of helping you guys out now?
like. So I think that my answer is going to be mixed on that. There are some sectors where there is an abundant amount of data, right? So anything to do with the web, anything to do where you have sensors deployed. Um, so in terms of vision, there is an abundant amount of data. But again, when we are looking for data in the cybersecurity area, we're really surprised at the lack of usable data sets.
Hmm.
We have been investigating since so many months now, trying to lay our hands on some system call data sets, event recognition data sets, and we have really come up empty-handed. When it comes to system call data sets, there are a few event data sets, event logs, but surprising dearth of data sets in cybersecurity. So I think that's a gap, and I think that's probably hampering a bit of data science and AI in cybersecurity.
That's interesting. Well, if anyone's listening in and if you know of something, please do drop us a note so we can probably kind of close the loop there. Um, so let's kind of get into the two broad areas of your research. So novel approaches to attack phase identification, and as I understand it, you guys are doing this out of log data, right? So that's a really interesting approach, and obviously people may have tried to do this kind of with just raw logs, right? So could you kind of walk us through what's the approach that you guys have taken? How is it different from what people are doing today? And sort of what can people expect with this research in terms of the outcome that they could get when you guys have this research out there?
Okay, so I think I would like Omid to maybe answer this question because he has been an integral part of this work and one of the students who leads this work in my lab. So yeah, Omid, would you like to take this one?
Sure. So thanks for having us on your podcast, I heard.
Yeah.
So a lot of work that is out there focuses on either program specific logs or program specific events, which we know has scalability issues and applicability issues. So you will be looking at through a limited lens, and when you're doing security by definition a no point for second place kind of game, you do not want to be doing that. So that's one of the main goals that we're doing. And then when you're dealing with raw logs as a lens through the system to kind of look at the holistic view in the same way, you will be dealing with problems of scale. And then these logs grow very fast, very, very, very huge, very fast, and how you control that. So in this uh, phase detection, we go beyond raw logs and we use them to create a summarization of the events. Again, a lot of work that is out there have used rule-based methods. They will go like if certain process does certain thing to a certain resource, or if certain process connects to the certain IP remotely, then we do a blacklist, whitelist thing. We know that is also very limited and quite frankly does not scale up to the real world of the attacks today. So we create this automated inference model that summarizes the raw logs, the system call logs, for all the programs in the same way, and it creates this encoding that tells us what is it that is happening. Is it a file edit? Is it a system activity? Is it a network activity? And then we further kind of subcategorize some of these activities into finer grained actions. What that tells us is A, now we don't need necessarily to store the whole big raw log multi-terabyte per day, we can keep these summarizations. And then these summarizations also have enough information for us to be able to draw conclusions on the higher levels that, like for our intent recognition and deception work. So we're kind of keeping a lot of information, doing a compression, treating the whole system, the whole universe of applications and activities through the same way, and we're trying to make it in a scalable platform. Like with a lot of traditional log processing tools like Elasticsearch and things of the sort, they're really awesome with indexing things. But when it comes to provenance tracking, or when it comes to anything that you want to analyze a long process, we're talking about APTs. And APTs are, by definition, not in a short span of time. So doing that with something that is just indexing things proves to be very hard. So we put everything in this compressed graph format of interactions, and that enables us to see a lot more than traditionally is visible, but a lot more detail. So that's kind of what we're doing with our attack phase detection. And we take these summarizations and we group them into, okay, can we say this is the file exfiltration, information exfiltration part of the attack? Can we say this is a compromise part of the attack? And these information are then passed on to higher layers, which I think Aditya will be better explain.
Yeah, and I would just like to maybe jump in here and say that so the summarization that Omid was referring to, we call them storylines.
Mm-hmm.
And so the idea is that our method essentially takes this raw logs, passes through a tool that Omid has developed called Graph, and we take the output of the graph, which basically allows you to focus on just the attack provenance and produce these summarizations called storylines. And essentially, the idea is that it gives you the entire story of the attack. And then we sort of learn these machine learning models. We throw these machine learning models on them and see if we can learn the individual phases of the attack. So that's our
And
entire pipeline. And we refer to this pipeline as Siberian. So anybody who is interested in trying out Siberian on their logs is most welcome to get in touch with us. The code is available. It's all open source, and we will be happy to help that company, help that group in seeing what sort of intelligence can they get from their attacks.
and I think that's a great a great offer. In fact, what we'll do is maybe if there are some links, we can add those into to the transcript notes so that anybody who's interested can probably pick up on those. I wanted to jump back, Omid, to you for a second. You made a pretty pertinent point about sort of alternative approaches, stuff like Elastic. And I was talking to somebody who operates in the SIEM space the other day, and he said, it's almost sad that I think he said out of like 40 SIEM vendors, like 32 of them are essentially just text search engines for the better part, right? And not just that, their usage, as you pointed out, in terms of having to store these mammoth amounts of data, it's not a surprise that it's charged by EPS or by gigabytes stored, right? So you make a very pertinent point. Now, something that you said, which was interesting, is you generate these storylines and then you can keep that summary and actually store that. And that's as I'm understanding, that's reconstructive, right? So is it lossy in some way? Supposing, and I'll tell you why I'm asking this. A lot of organizations have to retain that data for a long period of time, right? Maybe contractually or for some sort of compliance reason, and that's a pretty big nightmare as they scale. But the reason they need to store that data is because they want to go back in time, right? So is it possible for you to take these storylines at some later point in the future and sort of look back, or is it sort of a very lossy process and it would be harder to kind of go back to a particular point in time on the system state through the summarization?
So the way we have approached this problem, well, the main focus of our storyline generation and the attack phases is not compression, although we do compression. Of course, we will lose some information, but we do retain enough information for us to go back and reconstruct the provenance graph. That is the purpose of the tool. Now, in this tool that we developed called Graph, we do multiple uh, compression options that go from no loss to super lossy. On the middle range, we've been able to process some about terabyte range stuff on a commodity computer with about 6 gigs of memory use. So it is a fairly good compression, but we do give the user the ability to maintain the amount of compression they want. But just if even if you just keep our attack phases, that would still be enough information to draw conclusions on later. So you would still be retaining a lot of your provenance. Basically, you will know what happened. You
Yeah.
might not have complete resolution to it, but
Yeah.
you will still know what happened, when it happened, who did it, and the important part of the information. And because we are organizing the whole thing as a provenance track, now we don't fall in the pitfalls like where elastic products will be. So we have to keep this huge table, and then joining back to that
Index.
table
Yeah.
will be very complicated and stuff like that because
Yeah.
we natively use the provenance graph as the main data structure model.
And do you envisage this being run? You did speak of it as a pipeline, so I'm guessing that's the approach that you see it as ingest, process, or is it more like a batch process on data which happens from time to time, or do you see it as efficient enough that you could process data as it comes in and kind of deal with it in pipeline?
Oh, it definitely is efficient enough to be used as a real-time pipeline. It can also do batch processing. So
Mm-hmm.
some of our own experiments have been batch processing, but most of our use cases where we are doing the deception work and all that, it's a real-time job. So we're ingesting the data as it comes. We're creating the provenance graph and doing the signals as they come. It's, I won't say real time, but philosophically have issue with a lot of these real time systems, but
Yeah.
we're very close to real time.
Awesome. And as it is today, if somebody wanted to play with this, how simple is it to set up? I mean, I know you guys mentioned you got the project open. Is it quite straightforward that what would I sort of need, like the quick start to get going? If I've got a bunch of data and I want to run it through this, how would I go about it?
So the pipeline is made of different sections. The first section is a log producer module. So we don't develop that. You can either use Windows ETW, you can use Linux audit logs, you can use Sysdig. We have had amazing results with Systigs, and it's very awesome with how flexible the outputs and details are. So we do support all of that. Our own main use case have been on Sysdig and Linux audit logs. The next step in our pipeline is a tool called Graph. All you need for that is just Java. It's available on GitHub, and all you need to do is just download it and run it. The code is available there too, so if you want to make changes and all that, it's fairly easy. Then we have two Python sections that do kind of define our universe where we're talking about storylines and attack phases. And then there will be a AI section that does the storyline generation. So all of that is fairly easy to use, I would say. On all of them, we have enough information for somebody to jump in as long as they understand basics of that technology to jump in and just run it on their own data.
Oh,
So
super.
I
That
would
sounds very
say
practical. Yeah.
you don't need you don't need us necessarily to be running it.
Okay. Okay, I think that's very interesting, and you've already sort of contrasted with sort of traditional intrusion detection application sort of use cases and the sort of approaches, right? So let's sort of shift gears to the attacker intent recognition, the deception piece, Aditya, that you've been working on, right? So as I understand it, you're sort of stacking these two projects. So sort of Omid's work is sort of an input to the work that you're doing, as I get it, right? So could you talk us a bit through you're a former Smoky, so you know a lot of the work that's been done in deception in the industry side, but there are obviously
Right.
multiple approaches on in academia. Could you talk us a bit through the different approaches that you looked at and how you decided to kind of go the route you're going, and then maybe deep dive us through, like Omid did, on how you've approached this problem? What are the use cases? What are the things you're seeing?
Right. So, well, I've been looking into how deception is being adopted by the academia for a while now, and a major player here is the game theory approach, where you define this interaction between an attacker and a defender as a game, and you try to disrupt the scanning actions of the attacker. So you try to feed him false data, and there's some guarantees on what probability uh, with what probability your attacker will be successful. And so that's one of the areas that the academy is heading towards. But then we decided to take more of an epistemic approach. So we thought if we could model the beliefs of the attacker, what the attacker is probably thinking when he's doing a particular action, that goes a long way in understanding intent, and that also helps designing better defenses. So we sort of had this bird's eye view of security. You can traditionally, like the good part of security in academia is mostly you have vulnerability development, you have vulnerability detection, you have automated patching and things like that. So what you do is you take a software, you rewrite it as a bunch of logic rules, and you run an SMT solver on it, and you say, okay, this is a buffer overflow here, this is a memory corruption bug here, and so you have various algorithms to automatically patch that and exploit that. But then we thought, okay, even if you can do this, even if you can automatically discover vulnerabilities, that is just one part of a huge cyber attack. That will probably get you in, that will probably get you a prevest.
Yeah.
But what after that? You have to navigate this whole network. You have to reach that resource that you're after, and that involves lateral movement. That involves all types of discovery. So we thought, okay, this is not a single one shot attack. It's a plan, and we need to find a way to model how the attacker plans this whole attack, and that's where we use this decision making framework called a partially observable MDP to model the attackers. And it has been used before. A few of the people have tried to model cyber attackers using POM DPs. That's what we call them. But then what's unique about our work is that we have an extension of a POM DP to a multi-agent settings. And that's called an interactive partially observable MDP. And it sort of looks at the POM DP and it's able to reason about what the attacker modeled as a POM DP, what's going through his head, what's his optimal action in this particular state,
Yeah.
and that really helps us get into the mind of the attacker, understand how he's thinking. And our work with intent recognition is basically based on this framework, the interactive partially observable MDP.
And this sounds like it's got tremendous applications, not just in, say, threat detection and predicting the future state, but even if you look at currently sort of growing area in the industry is the breach attack simulation space, where essentially right now the breach attack simulation tools are dumb, for want of a better word, right? They have the capability to run those different attack phases. To your point, they can run the buffer overflow and create the observables, but there you need a human being to stitch together the playbook, and there's no element of uh, what is the cognitive state of the attacker and maybe some probability weightage to how he would choose a particular direction. That's really just human driven, like, okay, first do this, first do that. So I think there could be some very interesting applications on top of stuff like MITRE Caldera. MITRE open source their framework for breach attack simulations. So probably some very interesting use cases outside of just understanding the bad guy. And this is an interesting question because we've dealt with this at Smokescreen a lot. Have you modeled for attacker frustration?
So we've done a lot of we've looked into how will model attackers just delaying stuff.
Hmm.
uh, and turns out that that's although that's a hallmark of an APT, just try to do this over a longer duration. You're essentially not doing anything. The attacker is just
Yeah.
being dormant there. So you don't need to count that as a game step really. You can because our framework is like a discrete framework. It models this interaction
Hmm.
in steps. You can declare a step whenever you feel that okay, now the interaction is taking place.
Yeah.
And so attacker frustration is, although like a realistic term, probably we should model it, but right now we assume that the attacker is a rational
Highly
person.
motivated, and yeah, yeah, because we've actually we had this interesting situation once where we had a red team going up against our technology, right? And the first time was zero knowledge, the second time was full knowledge. So the zero
Mhm.
knowledge was in some ways easier because we were sort of doing path encouragement, right? We were saying, okay, we're going to give you interesting things to go after, and therefore they would go after them, and we made sure that the probability was high that they would pick X versus Y. The
Right.
second time was a much more different exercise because they're aware of deception, they're aware of that this is in the network. So what we started doing was path denial. Essentially, we would start dazzling them. So, for example,
Mhm.
say they were dumping credentials out of memory, where earlier we may have given them 2 or 3 juicy credentials. Here we would give them 500. And the interesting thing was what we saw. Obviously, this was not a scientifically sound process, but in this particular anecdote, we saw that their frustration levels were actually, and their ability to operate was reduced in the second situation, while you would have expected that being deception aware, they would have had more ability to, take better decisions. But the fact that they were now overwhelmed with data, they actually started backing off from things that looked real. There was quite an interesting interplay there between the deception aware and the deception unaware adversary. But
Mhm.
what's sort of the state of the research today? I mean, is it still fairly new? Do you guys have use cases operating? Kind of to how Mead walked us through where you guys are. Where does the research stand today?
So I'd say the IPOMDP framework, it really handles the interactions well. And what one of the nice things we've observed is that as a matter of pure coincidence, the optimal policies that are defender agent computed, they were pretty related to MITRE's shield, and
Okay.
a lot of the actions that our defender agent was doing, or we modeled it to do, we found that there's terminology in the MITRE shield matrix that
Yeah.
actually describes those actions. And so it's just an interesting development that it is in a way tied to practical applications of active defense.
Yeah, and I guess that's probably great for you guys because there's so much stuff which is MITRE ATT&CK mapped, and MITRE Shield, for those who are not familiar, is MITRE's new active defense framework. It talks a lot about adversary engagement and deception, and it's cross-mapped to MITRE ATT&CK. So if you were to find something with, MITRE ATT&CK mapping, even if it's a data set, or even if you were building this technology further out, you would be able to leverage Shield and the cross-mapping, I suppose. So the Shield guys have done a lot of great work, and we're sort of pretty thankful to them for actually bringing active defense out of sounding like some sort of weird buzzword into something that people can talk about rationally. So I think that's been a good thing. Dr. Doshi, I wanted to circle back to you. Um, this idea of the cognitive element in the research that you've got here, it's obviously it's hot topic in the industry. A lot of sort of folks are working on it. It's obvious you guys are on the sort of cutting edge as far as this is concerned. With both these two projects, what's the state that you would like them to reach? Like, what's kind of that moment where you're like, wow, that's a really nice use case? Or, Aditya comes knocking on your door. He's like, hey, we solved for this. We tried this and we saw this. Maybe I'm kind of making it as sort of an overarching statement, but do you have sort of like a place where you're happy with where you've reached with the research in its practical application?
Yeah. So I think, yeah, I'm already happy with, I think, the progress that we have made in terms of face recognition and intent recognition, especially the intent recognition work. I know that Aditya and the rest of the team has put in a lot of effort to make this pragmatic. We are using a fairly pure decision theoretic framework, and then showing how it can be used in a cybersecurity domain. And this is a fairly large domain, for the framework. So I think this is probably one of the largest domain application for that framework. And so I think I'm fairly happy at what we have managed to achieve so far in terms of showing, what active defense can do and how it can be used to deceive the attacker so that you can prolong the engagement.
Mm-hmm.
And the more engagement is prolonged, the more you know about
Done. Yeah.
the
Mm-hmm.
attacker. So like I think in one of our previous calls, you had said that Smokescreen was involved in a 17-hour engagement
Yeah.
with an attacker, and that just really blew my mind. That's
Yeah.
exactly where we would
Nine
love
and
to.
a half hours in one decoy alone, and then from there
Right.
moving around. And yeah, it was very interesting. I mean, as you rightly pointed out, they're showing you more and more of their hand. Even just
Exactly.
uh, the simple thing of human versus automated is just so
Right.
interesting to look at. So, yeah.
Exactly. And all of this work has been published. So anybody who is interested in reading about it, is welcome to contact us, or is just welcome to do a Google search, and they will find all these papers. Now, what we are doing next is even more exciting. So we are collaborating with a psychologist, and we are trying to see how can we exploit the cognitive biases that lead people to get deceived to help with cyber deception.
That's so cool.
So, for
Okay.
example, we have already investigated a few of the cognitive biases that play a role in generally people getting deceived.
Mm-hmm.
So, a few of them, I'm just going to name them. Don't ask me to define them because this is all psychology speak.
Mm-hmm.
But basically, some of the cognitive biases are framing, transference, and fundamental attribution error. So we are focusing on a few of these cognitive biases because these are known to play a role in getting in people being deceived. And we are trying to see how can our AI exploit these biases, which are there generally in humans, and facilitate their deception. Because after all, the attacker is, the attacker may be hiding behind bots and some scripts, but after all, the attacker is still human.
Human being. Yes.
So this is, this really would blow my mind. If we can actually incorporate these cognitive biases into our AI, so that the AI knows that, if I were to perform action A, is actually going to trigger this particular bias in the attacker, which
Right.
might actually lead him to accept our decoy or to enter this particular host, and then we can engage him there. So so that's what Aditya is working on next. And right now we are still at a stage of understanding these biases better, and also trying to arrive at computational models of these biases, which is a bit lacking in the literature.
Mm-hmm.
But if we can integrate these biases into our framework, which makes it a truly cognitive framework that also is now aware of the biases that the attacker has, as being just simply because the attacker is a human, and
Mm-hmm.
most humans suffer from these biases.
Yeah.
There's not really much you can do, about that.
Yeah.
I think that if we are successful in showing use cases where we can actually deploy these biases and exploit them, um, I would say that that's an amazing accomplishment, for this work.
That is, I mean, I think that's something which so many of us have talked about in conversations, which it's really where all of us on the industry side of deception have wanted to get to. We want to make it not a software versus software problem. We want to, bring in that software versus human element. And I think that's really interesting. Um, so I just wanted to put out a thought to Omid and Aditya. So, if Dr. Doshi woke you up at 4 o'clock in the morning and said, "Hey guys, we need to show a 5 minute single use case demo of both the projects to somebody tomorrow morning 6 a.m." What's the one you would go to? What's the like the this one works every single time. It looks awesome, and everybody goes, "Wow." What's the two for each of you? Decide whoever wants to go first.
Well, I will go back to bed and leave it for Aditya.
Good answer.
Well, I mean, is this about our work in the lab?
Yeah.
Right. So I obviously choose my project because yeah, I'm emotionally attached to it because I've worked on it. But on the nicer side, what you really get to see through my work is the mind of the attacker. You see what he's thinking, what probabilities he assigns to
Mm.
particular states of the world. So when this interaction is running out, you can actually see when you deceive the attacker that the belief of the attacker is like highly biased towards him believing that this is true data, and there's less probability mass over the existence of decoys. So you can see these probabilities shifting when the interaction is actually
That's
taking
awesome.
place, and I think that's pretty cool.
Yeah,
And
and
Omid,
you know
what? Yeah.
we have actually been running some experiments here with cybersecurity students. Where the students serve as a red team,
Mm-hmm.
basically connect to our host, and then our tool tries to actively deceive them.
Deceive them. Yeah.
And so we have some data that we have been collecting on those interactions with actual cybersecurity students, and I think those that the data has been quite revealing, right? We actually have it. We have published that document as well.
Right.
And Omid, what? Yeah, sorry. Go ahead, Aditya.
Yeah, I mean, just another point to add to that. One nice thing about like the project that I worked on is the interrecognition part is that you can actually integrate different tools as the observations to that framework. So if you have your intrusion detection system, or if you have your log analysis system, the predictions from those systems can tie in as observations to our model, and so it's basically highly integrable. You can have different existing uh, industry implementations of different aspects of cyber
Well, we're
defense
quite we're
into.
quite excited to see it. I mean, we've been toying with the idea of having kind of like demo day podcast sessions as well. So I mean, maybe we bring you guys on to kind of show us, actually show us a run through, right? And Umid, I'm
Right.
not letting you go. What you still haven't given us a good answer.
Uh, After I wake up, I'll probably, I would say, probably the most interesting part is still IoT's work and how much we can learn about the attacker. And I'm very excited about the future, integrating these biases and the more human part uh, into the whole system. To me, that is very exciting. To me, it brings up the old hidden laws of a probable outcome lyric.
Yeah.
So it is that part, although it's not mainly my work, it's Aditya's work, but that to me is the most interesting part, I would say, in this track of work.
And before we close up, Dr. Doshi, I know you've done a lot of work sort of with industry and academia, and both the guys on the call have industry experience. So, what are your views on taking this to the next level? Are you looking at partnering with folks in industry, and what are sort of the next steps for the research going forward?
Right. So I think I would love to partner with the industry. I would love to partner with Smokescreen, and I've told Aditya to stay engaged with Smokescreen. One of the things, as I mentioned in the beginning, is really the lack of system call data.
Hmm.
Right now, we would love for the industry to step in and maybe release some system call data that is known to have attacks embedded in it.
Hmm.
Of course, the data should be anonymized. Um, but if the industry can probably provide this kind of data sets, I think it will help academic labs like mine a lot, because there really seems to be a real lack
Mm.
of such data sets. So that would be sort of one aspect that I would like to collaborate with any industrial partner. If we can get some data sets that we can use in our work. Other than that, I'm happy to transfer this technology. If there is somebody who is interested and who would like to take a shot at this technology, I'm most happy to work with them, to consult with them, to transfer this technology onto their units. It can be a formal transfer agreement, it can be an informal transfer agreement, either way. So yeah, I mean, we would be very interested in translating this work out into the real world and into the industry.
Awesome. Well, guys, this has been a really fun one. And again, thanks for coming on. We're going to put links to your work in the transcript. So once again, great to have you, and we look forward to bring you guys on again. We might even want to go in a bit deeper because I think the work is really interesting. It's super interesting to me. I think obviously I come with a bias in that sense because I'm in the deception space, but I think this is really like fundamental research in what cybersecurity should be going towards. So superb, fun talking to you guys. Good luck with the research, and if anybody wants to partner with the lab, we'll provide their contact information in the transcript as well, so they can get in touch with you as well.
Okay, thank you, Sahir.
Yeah.
Thanks for having us, and I think it was really great,
Yeah.
being on this podcast.
Great. Thanks, guys. Thanks, Dr. Doshi. Thanks, Amit. Thanks, Aditya. Talk soon to you guys.
All right.
Thanks for having us.